In the diagram, AB is equal to B plus C, BC is equal to 5B, and AD is equal to 3B minus 2C. Express in terms of A, B, and or C in simplest form, the vector AC. And so what we have here is we have AC. What does that mean? That means that we start at A and we end at C. And so in order to get from A to C, we're gonna say, okay, let's go from A to B, right? So we're gonna go from A to B. And that's why we have AB here. And then we're gonna go from B to C. We're gonna go from B to C, all right? And so that's what we have. So we have AC is gonna be A to B. So A to B, and then B to C. So B to C. Now what is AB? Well, AB is B plus C. That's what AB is. AB is B plus C, B plus C. And what is BC? What is BC? BC is going to be what? 5B. BC is 5B, all right? And so AC is equal to B plus C plus 5B. Next thing we're gonna do is we're going to group together the like terms. And so we have B, right, plus 5B, and we put the C here. Now, what is B plus 5B? Well, B plus 5B is definitely 6B. And so AC is equal to 6B plus C. Next, we are going to determine what is DC. Now, DC means that we start at D, right? But we end at C. Okay, that's what DC means. So we're gonna move from D to A, right? So from D to A, right? From D to A, and then we're gonna go from A, we're gonna go from A to C. And the reason why we go from A to C, because we already know what AC is, right? AC, we just figured that out in the previous question. So we're gonna go from D to A, and then we're gonna go from A to C. Okay, what is D to A, all right? D to A, if you notice carefully, that, let me use this pen. D to A is actually going in the opposite direction of A to D. So D to A is going in the opposite direction of D to A. I'm sorry, D to A is going in the opposite direction of A to D. Let me say that again. D to A is going in the opposite direction of A to D. So what that means that since it's going in the opposite direction, we're gonna put negative AD. Again, D to A is going in the opposite direction of A to D. And so that means that we're gonna put the negative sign. The reason why I put the negative sign is because that's saying that, hey, D to A is going in the opposite direction of A to D. And so what does that mean? Since A to D is equal to 3B minus 2C, that's what A to D is, but we're going from D to A. So we're gonna have to have minus 3B minus 2C, okay? Because we're going in the opposite direction. So A to D goes 3B minus 2C, but D to A goes in the opposite direction. So it's gonna be minus 3B minus 2C. And then we put plus 6B plus C. And that's what AC is. That's what we determined earlier, right? AC is equal to 6B plus C. And then we can distribute. So we say -1 multiplied by 3B. And that gives us negative 3B. We say -1 multiplied by negative 2C. And we have a negative times a negative, which is a positive. And so this is positive 2C plus 6B plus C. The next thing that we do is we group together the B's. So we have a negative 3B plus 6B. And then we have positive 2C plus C. Next, we say, okay, well, let's work on these two terms, negative 3B plus 6B. Again, negative 3B plus 6B is equal to 3B. And 2C plus 2C, we bring that down. What is 2C plus 2C? 2C plus 2C is 3C. So we have that DC is equal to 3B plus 3c. We factorize, oh, I didn't factorize, I just leave it as such. But we can factorize it. If we factorize it, we can factorize the DC. We can factorize the, we could factorize the 3. So we could take the 3 out. If we could factor out the 3, that's what I should say. So if we factor out the 3, we're going to be left with what? B plus C, right? B plus C. So that means that DC, right? That means that DC is equal to 3 open bracket B plus C. And it makes sense because 3 times B is 3B and 3 times C is 3C. Okay, next, they want us to write 2 geometrical properties of vector AB and DC. Now, what is vector DC? Like we saw in the previous question, vector DC is equal to 3B plus 3C. And if we factor it out, it gives us 3 open bracket B plus C. Now, what is B plus C? Well, B plus C, this is B plus C right now, right? B plus C is vector AB. So instead of writing B plus C, let's just write vector AB. And so we have 3 times vector AB, which means that if we take 3 and we multiply it by vector AB, that means that we can get vector DC. And so what that means is that these 2 vectors are scalar multiples of each other. That's why we have this here. The vectors DC and AB are scalar multiples of each other. And that means that if we have this scalar 3 and we multiply it by 1 vector, we get the other vector. That's what it means for 2 vectors to be scalar multiples of each other. If we take this scalar and multiply it by this vector, if we take this scalar and we multiply it by this vector, we should get this vector here. And so since DC is equal to 3AB, this means that the vectors DC and AB have the following properties. All right, so the first one is that the vectors DC and AB are scalar multiples of each other. And since they are scalar multiples of each other, we can say that they are parallel. That's what it means to be parallel. 2 vectors are parallel if there exists a scalar multiple such that if we take that scalar multiple and multiply it by the vector, we get the other vector. That's what it means to be parallel. So the vectors DC and AB are parallel. They are scalar multiples of each other. They have the same direction because 3 is positive, and vector DC is 3 times longer than vector AB. And so they only ask us for 2 geometrical properties, right? So I would use that they are parallel, right? And I would use that DC is 3 times longer than vector AB. And that's the answer to this question. Okay, that brings us to the end of this video, and I'll see you in the next video.